Hi everyone, welcome to Vishwablooms. So in this video, we will be looking at Science Class 10 CBSE first chapter, that is Chemical Reactions and Equations. So let's begin with the chapter. So in the beginning, let's have some introduction. Now this topic is a chemistry topic actually. Now first we should know why chemistry is very important. Why should we even understand chemistry? Understanding chemistry, it will help us to understand the entire world. Okay, and you know everything from cooking, touching, tasting, smelling, all these activities, it is coming under chemistry only. All this is chemistry only. Now the building blocks of the chemistry is elements. As you know, the modern periodic table contains 118 elements, so these elements are the building blocks for chemistry. Now the after learning the building blocks, it is also essential for us to learn what is electrons, protons and neutrons. Right, so already we have been studying in our ninth class, but let's have a glance over it. Electrons. So all the atoms will contain negative particles. So these negative particles are called as electrons. It is denoted by E minus. Okay. So now generally there are energy levels like this. Okay. This will be energy level 1, 2, 3. These energy levels are in oval shape. Okay, like this. They are in orbital shape and they form all orbitals. Here you can observe in the figure. So in the center, it is the nucleus, right? We know this. So nucleus has proton and neutron also. Proton P plus and neutron no charge. And all these negative you can see, right? These are all electrons which are revolving around the nucleus. Fine. Now in the you can observe three energy levels. This is the first one, as I've already marked in the figure. This is the second one, and the last one is the third energy level. Now Now, we should also know the number of electrons which can be accommodated in the energy levels. So, in the first energy level, that first energy level or the orbit is called as K shell. This is L shell. This is M shell. Okay. Now, first shell will be K, second is L, and followed by the same or series of letters. Okay. So, first K is nothing but 1. So, it is the first shell, right? So, N is 1. The number of the shell is 1. And for L, it is number is 2. And M, it is number is 3. Okay. Now, how do we know that number of electrons present in the energy levels? For that, we have a formula called 2n square. This rule, by this rule, we can know the number of electrons which can be accommodated in the particular energy level. Now, when you are taking the K shell, as I told, the number is 1. Now, when you are just putting that value into this formula, 2 into n is 1. So, 1 square, it is 2 only. So, that is why you can observe there are only 2 number of electrons. Now, moving forward with L shell, here n is 2. Now, 2 into 2 square, what is it? 2 into 4, which is nothing but 8 electrons. So, in the second shell, we are having 8 electrons. And moving on to the third shell, here n is equal to 3. Now, putting in the 2n square formula, 2 into 3 square. Now 2 into 9 is 18. So 18 electrons can be accommodated in the L shell or the third shell. Clear? Now this is about electrons. Now when these electrons, sometimes what will happen, here you could see all it is fulfilled. Sometimes what happens is, here there will be 2 electrons, here sometimes only 1, and if other electron needs it, suppose it is in the need of it, it will take it. That time there will be charged particles. So this will take it, right? It can even share or steal or even beg. So that taking of electrons, that is ion. So that time what is happening, it is lending and it is taking. So these kind of charged atoms are called as ions. So in order to fulfill their inner energy level, they will just share or even steal the electrons from other atoms. Now generally, as you can observe here, first first they will try to fill their innermost shell, that is the K shell. First they will fill, then with L shell, and then M, and so on. Okay, the unfulfilled ones will be mostly in the valence, that is the outermost shell. Generally it will be okay. For getting that, it will shed, share, or even steal, and sometimes beg also. Now next part, after learning the electron, then we have to learn about the nucleus. Now already I told you the proton and neutron are present in nucleus. So nucleus is nothing but change in number of protons as well as neutrons. Okay, now that is about nucleus. Now coming back to other topic, this is all about energy. Okay, so as you all know that E is equal to mc square. This formula was created by Einstein. You know that, right? He gave this formula. In this formula, what is going to happen, this M is the mass is converted into energy. So that's what, right? When a atom bomb explodes, what happened? The full explosion, right? So here what is happening, The mass is getting converted into energy. Okay, let's just leave about that. Now getting back to our points. Here, always remember, mass is being conserved and electrons are shared. This is just the summary of all the points which we have discussed. Next is the next part is little important because it is the way how we can detect that some chemical reaction took place. So that is very important. So let's learn that now. So to determine the occurrence of chemical reaction, so what are the major things you have to keep in mind is change in color. So when change in color is there, there would be a occurrence of chemical reaction. Change in temperature, change in state, and evolution of gas. So these are the factors, like some of the ways in which you can know that a chemical reaction has occurred or taken place. You can just have the gist of that here. Before moving on to the next topics, let's just revise physical changes and chemical changes which we already learned. So first, what are physical changes? It's very simple, as we all know the answer. It is just these physical changes are the changes that will just affect the state or appearance of a chemical substance, but it will not affect the composition. Now, there are two examples in front of you. You can see that here. When a pencil is being broken, what is happening? Just we get two bits of the pencil, right? Here one bit, another one, right? But there is no change in its composition. It is the pencil only, right? Next, second example we are having ice. When ice is being melted to water, again, you can from the frozen ice we are able to get water, and similarly from this water again we can get the ice when it is kept at 0 degrees Celsius, right? So that is what this process is reversible. So as we all know, physical changes are always reversible, most of the cases. Next, moving on, chemical changes, just the opposite, right? So here, this is just irreversible, as you know, right? The chemical changes is the one that will results in formation of new chemical substances, and this chemical changes, it will lead to some change in chemical composition, as we know this already. Now let's take two examples again we are having on the screen. Example one is cooking. It's something related to cooking, right? So when you are taking egg and when you're putting in an omelette, can you get back the omelette as egg? Can you get back the egg from omelette? Obviously no, right? Now when you're burning the sticks, burning wood, now only what will be there? Only the remains. The ashes will be there. But will you get wood back again? No, right? So this is the chemical change. Next is fire triangle. So this is nothing but what is fire triangle? It is a name is a little bit different, but it is very common thing. Now fire triangle says for getting fire, for obtaining the fire, what are all the things necessary? That is all about fire triangle. Now when you want fire for warmth or for cooking purposes, generally what do you need? First thing you need is fuel. Without fuel, obviously, the fire can't come, right? You can't generate fire. And second most thing is heat. You need heat for it. In a cold region, you can't get fire. In the sense, like with burning of sticks, you can't get it, right? And main, oxygen. Oxygen is very much important in burning processes. So suppose when you are burning some wooden sticks, wood is actually made of starch. So in that starch, what is there? Multiple units of sugar. Now what is the formula of sugar? C6H12O6. That is the formula for wood. Okay, so now when this person A wants the fire, what will he do when he has wooden sticks? First he'll burn that wooden sticks, then in the presence of oxygen, what are all the results he's going to get? He's going to get carbon dioxide, he's going to get water and heat energy from this. So for cooking it will be satisfied, for the warmth everything it is satisfied for him. Now this C6H12O6, what is this consisting of? C6H12O6 is consisting of 6 carbon atoms and 12 hydrogen atoms and 6 oxygen atoms. Fine. That is clear to you all, I hope. So with this 6 carbon plus 12 hydrogen plus 6 oxygen, wood is being made. That is the formula of wood. Fine. Now, obviously, you should remember one thing. Chemical compounds are also named after composition. Chemical bonds between atoms of different elements. So first main thing, see, always these chemical compounds, they are named after composition. Now when you want to ask a person, suppose 50 grams of sugar is easy for us to tell, or C6H12O11. Obviously sugar is easy, right? So that is what their names are being given for them. That's why it is wood here, right? Next part is chemical compound. Chemical compound is defined by the ratio of each type of atom involved in the compound. So ratio of each type of atom. Now here how many atoms you can find? In this example C6H12O6, obviously there are 3 atoms. Now they are asking the ratio. What is the ratio of this? For carbon, there are 6 carbon, 12 hydrogen, and 6 oxygen. So they are, mixed in a proper ratio, some proportional ratio that is involved in the compound. So what is the 6 C12H C6H12O6? It is glucose, which has been present like stars we have discussed, right? That is what we have given the formula for it. Now, just now we have seen wood plus oxygen gives rise to, it gives the carbon dioxide, water, and energy. Now, if previously how we wrote like wood, when wood is being burnt, in that story way if you write, it is very tough for us to understand, right? So we have written in the form of word equation. So when something is being written in full names, that is called as word equation. Suppose now I am taking one example. Mg plus O gives rise to MgO. Sorry, MgO. OMG. So now how you have to say this here, you're going to write everything. Magnesium, this is word equation. Magnesium plus oxygen gives rise to magnesium oxide, everything. When you're writing it in a full form, it is called as a word equation. Okay, then what is chemical equation? This is the chemical equation. When this word equation is being converted into their chemical names using their symbols, the elements are being represented using their symbols. And in this chemical reactions, you should also remember their proportion also will be written. Now in this wood, you would not be able to understand this many C's are there, this much of carbon, this much of hydrogen, this much of oxygen. You won't be able to understand in this, right, in the word equation. But whereas in the chemical equation, you would be able to understand the ratio of each of the atom present in the equation. Clear? Now same equation, let's consider in the word form only once again. So first and foremost thing, how do we write a equation? Just take the word equation. Now in this previous first, wood plus oxygen, this is gives rise to, you're not supposed to put equal to as you put in maths, it's wrong. You have to use gives rise to. This arrow mark shows or indicates gives rise to. Fine. Now whatever is there left side of the arrow mark, the side whichever the arrow mark is not showing, these are all called as reactants. Wood plus oxygen is reactants, and the arrow mark whatever side it is showing, those are all called as products. These are all these are all being formed after their reaction only, so that's why they are products. And now wood, what is wood actually? It is a solid, you know that, but in order to specify that, you will just write S in brackets as shown here. And what is oxygen? It is gas. You will write G in brackets, small g. And carbon dioxide is also gas. These both are gases, so small g will be represented. Now water is in liquid form, so in bracket you will just write small l. Fine. So that is what you're going to mention. That is clear to you. Next part is this small triangle which I drew. Before learning that, we have to learn aqueous and precipitate. Then we will be learning about that small triangle. And here heat I have written, right? So in the presence of heat, wood plus oxygen in the presence of heat, because that triangle, fire triangle, has heat also in it. So that should be specified. But you can't just write plus heat here. You should not write that. It is wrong. You're going to write heat just below the arrow mark. Okay. That is, now this part is clear. This heat is clear. This reactions and products is also clear. Except the small triangle gives rise to is also clear. Now let's learn aqueous and precipitate. So aqueous. First thing, when there is some solution which is mixed in water, that is called as aqueous solution. So just to read the definition, if the reactant or product is present in the solution in water, it is present as solution in water, then it is an aqueous solution. So when that is there, you will just specify AQ in brackets. Next is precipitate. If salt precipitates out of the liquid after reaction, then that is precipitate solution. Okay. Now this is simple only. When there is some liquid, from that solid will be precipitating after the reaction, that is precipitate, then you will be using PT. Okay. So now I'll tell you about this arrow mark. This arrow mark, small arrow mark, this triangle which is above the arrow mark is the change. Actually, it determines the change. So here you can see that wood plus oxygen plus heat is being changed, right? Its state is being changed from solid and gas, it became liquid and gas, right? So that change it is showing. That small triangle will be showing a change. Now already discussed that these two are reactants and products. This is just the summary of that. Now just observe the equation clearly. On the LHS side, how many number of carbons are there? Just see the first thing. First element is carbon here. Now you can see 6 carbons in the reactant side. So let me write nearby reactants. 6 carbons. And on the product's hand, you could see only 1 carbon. 1 carbon. Now do you think that both are equal? Obviously not. And due to this equation is not balanced, as well as it is violating the basic law of conservation of mass. Now what does the conservation of mass law state? This law states that mass can neither be created nor be destroyed. Okay, unless it is a nuclear reaction. So that is I have mentioned in pencil because that is not necessary. We are not going to learn about nuclear reactions. So this statement we have to stick on to. So what we have to do, we have to balance the equation so that here 6 carbon should be balancing with 1 carbon. So here at least it should be added. Obviously you can't deduct because it can't be destroyed. Only here you can be added. So that balancing of equation also we'll be seeing. This brings us to the end of the video. Thanks for watching our video. Do like, share and subscribe to Vishwablooms, and we'll see you in next part. Until then, bye, and don't forget to subscribe.